Microsoft Excel is a fantastic tool to address statistics and probability questions. And so I want to go over a few functions built into Excel that cover descriptive statistics. And then also I feel like you have to see how Excel can handle the normal distribution questions, which are so common in a statistics setting. All right, so what we're going to do here is, first of all, I already have this spreadsheet set up in a way where I'm going to have a column of values in B, and then I'm going to run some descriptive statistics from in column D. In particular, we're going to count the number of things we have, we're going to add them up, look at their mean, find their minimum, their second quartile, their median, the third quartile, the max, and then the standard deviation. Okay, we're going to start off doing that. And the way we're going to do this is we need a data set, and remember a good way to do that in Excel is with a ran between function. And so this time I'm going to use ran between 1 through 10 to generate a random number between 1 and 10. I get the number 5, and I'm going to drag that down to A26, and I could keep going if I wanted to. Okay, so there I have a randomly generated set going from A2 to A26, and I'm going to copy that, and then in B2 I'm going to right click and hit paste values, and that way I just paste the values that I have in here. And so every time I do a calculation, my data set doesn't change on me like it is in column A, bouncing around everywhere. Alright, so there's my data set. Now I'm going to show some descriptive statistics functions built in Excel, and they all work pretty much the same way. So for example, count, I think we've done this one before if you've worked the previous exercises. We're going to say count, and I'm going to reference the cells B2 down to B26. And when I do that, it counts, and I have 25 data points in my set, which is what we knew because we're going from 2 to 26. That's 25 things. All right, now to do the sum, I'm going to do the same thing. I'm just going to use the sum function, B2 down to B26, and this is adding everything up. In case I needed to know that, you may need to know that to calculate the mean, right? If you add it up and divide by the count, that's the mean. Well, I don't have to do that in Excel actually, so to calculate the mean, I'm going to hit equals average. Average means the mean here, and we're going to go from B2 down to B26 just like we did the other times. Click, hit enter, and there's my mean value for my data set. Alright, so now we're going to kind of bounce around a little bit to calculate the min, the median, the max. So for the min, I can use the min function, and again I'm just using B2 to B26. Hit enter, there it is, right? So for the max, I hit equals max function, B2 down to B26, hit enter, and there it is. My max is 10, which is understandable. We look at our data set, we're picking random numbers between 1 and 10. There's a min at 1, there's a max at 10. Okay, so for the median, which is the middle value, remember, I can hit median function, B2 down to B26, and hit enter. We get 5 to be the median. Okay, that's the middle point of my data set. If I arrange this data set in numerical order and looked at the middle value, which for 25 values, that'd be what? The 13th value would be the number 5. Alright, so to get my quartiles, I'm going to use the quartile inclusive function. We don't have to worry about the difference between inclusive and exclusive. We're going to go from B2 down to B26 and specify what quartile we're wanting here. And we actually want the first quartile. I wrote Q2, but I meant first. We want the first quartile. So I should actually change this to Q1, and we get 2 there. All right. And if I go down to D8, I can do the same thing. We do quartile inclusive, B2 down to B26, and this is my third quartile, so enter, and there it is. There's my third quartile value. Okay, so that would be the 75% mark, 50% mark, 25% mark. There's the 0% at min and 100% at max, which actually, you know what, we could have done, use the quartile inclusive function for the min, if I hit the 0th quartile, and the max as well. B2 to B26, this is the 4th quartile, the 100% mark, and actually the median as well. I could use the quartile inclusive, B2 to B26, and this is the 2nd quartile. So notice I got the same values as the min, median, and max functions. I could use quartile inclusive for those as well. All right, now in D10, we're going to calculate the standard deviation, which is ST dev dot, and notice there's dot P for population, dot S for sample. So we're going to use stdev.s, which is sample standard deviation going from B2 to B26. And this will calculate our sample standard deviation there. And this is a whole lot easier than the algebraic way we calculate standard deviation by hand, with subtracting everything from the mean and squaring that and then adding them up, dividing by n minus 1 and taking the square root, etc. Okay, so this is a good bit easier than doing that, right? Agreed. And one thing to point out here in column C is that the column's too narrow to actually write standard deviation or standard dev. So you can go up to between C and D and just double click and it'll stretch it out for you so that you can see everything. I'm going to go ahead and do that for column F as well so that it stretches out enough. Okay. And here we're going to switch gears to look at the normal distribution. And so the normal distribution shows up in a wide array of contexts in surprising ways sometimes. So here's the example we're going to use just to illustrate the normal distribution. All right, so suppose heights of lavender plants are normally distributed with a height of 21 inches and a standard deviation of 4 inches. And now suppose that you select a lavender plant from your garden randomly, all right? And we're going to ask some questions about it, all right? So the first thing is let's chart down our mean. In G2, I'm going to write 21 because we said the sample mean from our lavender plants was 21 inches. And we said our standard deviation is 4 inches. Remember, the standard deviation kind of models how spread out our data is. All right, and so here's the kind of question we're going to ask. So we picked out a random plant, and we want to know, first of all, what's the probability that this lavender plant had a height of 22 inches or less? And in cell F5, I'm going to go ahead and write probability that X is, I'm going to write LEQ, which means less than or equal to 22. So I want to know the probability that X is less than or equal to 22. In other words, if I just pulled out a lavender plant randomly, what's the probability it's going to be 22 inches or less if the average is 21 and the standard deviation is 4? All right, now to calculate this, we're going to use the norm.dist function. And notice what it needs. It needs an X value, in other words, what we're going to test for, a mean, a standard deviation, and this cumulative thing is something that's a little complicated we don't have to really worry about. For our purposes, it's always going to be true. So just write true. All right, so here for norm.dist, we're looking for X less than or equal to 22. So I say 22, my mean, which is G2, standard deviation, which is G3, and then I'm always going to write true, and there's my probability. That's the probability that one of my plants is going to be 22 inches or less. So about 60% chance of that happening. All right, let's try some more. So what if your lavender plant's taller than 22 inches? What's the probability of X being greater than 22? All right, now we could calculate this in a couple of ways. One way, probably the easiest way, is by recognizing that's the complement of what we just calculated. So that'd be 1 minus G5, right? There's my probability. But I want to use a normal curve situation here. So instead of saying G5, I'm going to use the norm.dist function because that's what I want to practice with. We're going to say, how do you do a greater than situation? Well, the Excel function for norm.dist only gives a less than or equal to value. So to do greater than or greater than equal to, we need to say 1 minus norm.dist of 22 or less. So that's going to be 22, G2, G3, true, which is exactly what we calculated in G5. So that makes sense that this is going to work, and we get about 40%. And hopefully that's not too surprising, right? These two things need to add up to be 100%. And I think we got it. All right, so question 3. What's the probability that we pulled a lavender plant and it has a height of 14 inches or more? A height, so here we're saying probability X is greater than 14. And actually we're saying more than that. We're saying greater than or equal to, right? 14 inches or more. So I'll say GEQ 14. All right, so we have we're calculating again the probability that X is greater than or equal to 14. Okay, so this is again a greater than situation. The norm.dist function in Excel only does less than. So what I have to do then for greater than is to say 1 minus the less than situation. So 1 minus norm.dist 14 with a mean of G2, a standard deviation of G3, and again we're just saying true. All right, any guesses on what this is? 14 or greater when your average is 21. Let's see. Wow, 95.99%, so 96% chance that your plant is going to be taller than 14 inches. That's pretty amazing. All right, so I hope this makes sense. This gives you an introduction to some statistics in Excel. Now, this is not everything you can do, but this is at least covering some of the highlights. All right, if you have any questions on it, please let me know. I'd be glad to help, and thank you for watching.